Good morning. My name is Jason, and I'll be doing the next talk. We're going to talk about application security tools. But before I get rolling here, I'd like to understand who it is that I'm talking to. So, developers in the room? Few. Application security practitioners? Few of those. General interested parties? A couple of them too. Excellent. So for some reason you looked at a thing on a board and you were like, I want to go to that talk. Or you were just in the last talk and you didn't want to leave. That's fine. My name's Jason. I'm a security consultant for a company called Aztec Consulting. We're based out of San Francisco. Our consultants are all over the place, so the office is in San Francisco. I live in Hilliard. Basically, what I do for Aztec is I either go into organizations that have an application security problem of some kind. Either they're trying to install tools or trying to put things together. Maybe they need a pen test done. I do application security pen testing. Help organizations build software development life cycles with security in mind. And I do training for all sorts of things: wireless, incident response, application security, all kinds of stuff. I'm a DIY enthusiast and a Columbus Idea Foundry member. I'm actually the person, one of the 3 people that made the badges you're all wearing. So if you're interested in Columbus Idea Foundry, install a QR reader and scan the code. I promise you it's safe. So what are we going to talk about today? Well, we're going to talk about some of the tools you probably already have. If you have any amount of application security installed in your organization, you probably have one of these tools. I'm going to show you specific things, though I am going to speak of them in generalities. For instance, I will mention Veracode, but when I talk about Veracode, really I'm talking about a static analyzer. We're going to look at things like AWS security. Just recently, I did application security work for an organization that said, hey, can you look at my AWS security groups and see if I have any problems? And it turned out they did. So I'm going to show you how I did that work. It doesn't cost anything, so it's pretty easy to do. If you have a Kali box, you can install it with one command line. We're going to look at things like searching through logs to find an attacker and using your logs to notify you that you're being attacked. A lot of organizations just don't do that. The majority of this talk comes from my experience with, it's about 2,000 companies I've worked with to build SDLC, secure SDLC. And when I walk in on day one, I ask a lot of the same questions and I get a lot of the same answers. What are you doing today? Nothing. Or we've got Fortify sitting on a shelf somewhere. Or we'd love to have a dynamic test go on in our QA environment, but we just don't know what to do. So I'm going to talk about some of the tools that you may have already bought and how to plug them together a little bit better so you can get a little bit more value out of them. The theme today is going to be integrate everything, right? If you have a Splunk instance and you are not looking at your web logs, you should look at your web logs, right? Integrate that piece. If you have a static analyzer, you should plug that thing into your IDE. You should plug it into your build service. All of these things should be communicating together to build an environment. We'll talk about how to use things like a dynamic environment, a dynamic scanner to improve your web application firewall, things like that. So some of the things that you're going to want to need in order to make this work. Usually you got to have somebody with scripting knowledge or experience on board in your organization, whether that be somebody that knows Perl or Python or some kind of Windows language. I'm not a big Windows guy, so I'm not going to mention them too much. And a desire to have your tools connect together, right? All of the things should be built so that they all talk to each other. It makes it a lot better. And it'd be a good idea if you had an architect, whether it's your security architect or somebody in your organization to architect how you're going to have all these pieces communicate. You can get a lot of data out of the things you already have, and you can use it to improve your security, as well as just to have a better understanding of your operational environment. So the basic framework is you go out and you buy some tool. This tool is going to generate data, right? But most of us don't use it. So we run Fortify, After we get the 500,000 results back from Fortify, we go through a false positive reduction step and whittle that down to 200,000 results and basically hand that report off to development and say, good luck. But there's a lot of data captured inside of those results, and we should probably be using that. Also, 200,000 results in a single report to a developer is like handing them nothing, right? They're never going to look at it. They don't care about that. And that becomes problematic. So we need to clean up the way that behavior is. So we can look at how our vulnerability scanners gather data. We can look at analyzing logs, getting things out of our dynamic scanning environment, for instance, or a static scanning environment, and take some meaningful actions on this stuff. So a dynamic scanner, for those of you who don't know, is a box that goes out to your website. Usually the first thing that it does is it grabs all of the hrefs on the site to figure out what links are there. Then it goes and visits the links to see if there's parameters, and then it'll start fuzzing those parameters, right? So I've got an input parameter for a search box. Does it take script tags? Does it echo the script tag back to me, right? If it does, that's a finding. It puts it in a report. But what if we just took that report and instead of handing it to development, we hand it to our web application firewall if we have one. This takes the signature part of web application firewall and makes it your signatures, right? It's your problems that you're trying to block, not the ones that some R&D guy over at F5 has figured out. If your search parameter has a problem and your web application firewall doesn't notice that, that's bad. So what you want to do is feed that data in, and almost all of the WAF solutions out there will accept any dynamic scanner's input, including mod security, if you have the commercial version. If you don't, then you got to write your own rules. But if you aren't running the commercial version, you're used to writing your own rules anyway. But dynamic scanners are really useful for a couple of use cases, right? As I'm saying, testing parameters in an automated way, it's not a bad idea. It's something that you should be looking at. Right? But what do you do with the output? Well, oftentimes you walk back to a developer and say, hey, the Q parameter on this search box, it's got cross-site scripting on it. And your development staff is going to go, okay, I'll fix that. And then they wonder, sort of when do they have time to do that? So the WAF can kind of be an intermediary step, right, to shore that up. It looks for new attack vectors that are out there. How many of you guys are running Angular? Couple of us. How many of you know about the Angular escape attack that came out a couple of months ago? One of us. And it's because you and I know Bill. And so when that new attack vector came out, the WAF signatures were all improved to detect that stuff. The dynamic scanner signatures were all improved to detect that stuff. So if you're running dynamic scanning, it's a good idea to tie your WAF into it and make it all work. I don't actually have a WAF to demonstrate this on. I've set this up a few times. It's really hard to just phone up Imperva and be like, hey, hook me up. They don't want to send you $200,000 worth of equipment to do a demo. It'd be nice if they did, though. But I am going to demo some of the other things. So some of the dynamic scanning products that are out there, if you don't have one already, there's plenty of them. HP makes one, or they went out and bought one. IBM did the same thing. There's a company called Akinetics. Veracode has one. Qualys has one that I'm pretty familiar with. W3AF, NTO Spider, Iron Wasp. There's over 50 of them. If you go out to SecTools Marketplace, there's a guy out there that's been testing these tools. He runs them all against the same baseline, and it can give you some pretty good information. Thing to really watch out for, though, is if you go out there, he doesn't list them best to worst. I think it's alphabetical or something. So the one at the top isn't the best one. You have to kind of search through it. We've done our own analysis on this, and we've found that some of the free tools are actually better than the commercial products out there. It just depends on your code base and what it is that you're doing. So like Skipfish might outperform HP for you, right? I doubt it, but it's possible. So some best practices. Scan in QA as well as production. Right. When things make it all the way to production, it's more expensive. If you go look at the FUD and charts on this, they'll explain to you that it costs 14 times more to fix a problem in production than it does to find the problem in QA and fix it there. Also, developers are used to having QA say, this doesn't work. And they have a communication mechanism to tell development that it's not working, right? Your security team probably isn't plugged into your developer Jira instance. And so that makes it a little bit harder to do this. But if you're finding things in your dynamic scanning environment and you want to automate that process, there's a really great tool out there called ThreadFix. And what ThreadFix does is it looks at all of your scanning output and hooks into your defect tracking system. This is produced by a group of guys called the Denham Group out in Texas. There's a freeware version as well as a commercial version. I haven't seen much of a difference between the freeware version and the commercial version, so it's a pretty good tool to get for free. It'll go to your dynamic scanner, pull the results, and open Jira bugs for you, or open Bugzilla tickets, or Git, or whatever your defect tracking system is. It'll hook it together and make it work correctly. Typically, what happens when you're using a dynamic scanner for WAF tuning is you trip across a parameter that's got some kind of problem, right? So my question mark, in this case, it's the name parameter after the question mark in the URI. Insert some kind of alert and then a token that tracks it as it goes along. So this is what the scanner is actually doing. And then you get some XML output or CSV or whatever, and you just dump that into your WAF. Most of the WAFs will allow for you to upload any of the commercial products that are out there as new rule sets. Some of them will monitor a folder. So you can just keep dumping things into the folder and they'll monitor the folder and auto-tune the rules for you. Anybody ever done an activity like that where you watch a folder and just automatically update? Becomes problematic, right? You're going to end up with rules, and then eventually there'll be a problem. So there should be a little bit of watching of this activity as you go along. Almost all the WAF vendors, as I said, work with all the dynamic scanning vendors. If you're using the commercial version of mod security, there's a little bit of an extra step where you go out to their website, dump in your results, and it will give you rules. But it only works on the commercial version. So keep that in mind. So some things to ask yourself. Do I have a dynamic scanner or do I have a need for one? Do I have a WAF or do I have a need for one? If the answer is yes, we have a dynamic scanner and yes, we have a WAF and they're not plugged together, that's a great integration point to allow for you to get things put together better. As a dynamic scanner gives you output that needs to be fixed, you should have a way to integrate that scanner into your defect tracking system. And like I said, ThreadFix is a great way to do that, but there's other tools out there that allow for it as well. If you're good with scripting languages, you can just script the whole thing, right? All right, so let's talk about static scanners. So static analyzers look at code. Right? Most of us have one. I've walked into, like I say, about 2,000 organizations to talk about application security, and just about every one of those organizations has told me they either have Fortify sitting on a shelf, or they have AppScan sitting on a shelf, or they've done something with Veracode, but they don't ever have a complete solution built out of this thing. Typically, it's run by the security team, right? Because tuning these things is difficult, understanding how all this workflow is going to go is difficult. But what happens when it goes to the security team? Well, it's already made it through QA. You're basically waiting to go to production until the security bottleneck occurs. And then somebody from security is going to be like, wait, you got SQL injection here. We're going to have to take this all the way back to the beginning. So that creates an environment where security is a contention point, and you never want that. It also creates an environment where you're too late in the process to fix things, right? How many of you have heard, well, we really need to fix this in a meeting, and the next thing that's said is, we'll fix it later, right? And it gets put into production. I've seen that happen a bunch of times. Oftentimes, static analyzers will output things that a developer doesn't understand. It needs to be explained to them why it's a bad thing. Now, if I say you're using a bad cryptographic key, or if you're using a bad cryptographic algorithm because it's an old version of PHP and it's running this thing, yeah, it's pretty easy to figure out. We upgrade. That's easy to solve. But if it's something like SQL injection in a dynamic part of a parameterized query, then it's a little bit more difficult to say, hey, wait, you're doing dynamic input here. Yes, thanks for using a parameterized query, but you've broken it. And so you have to go through a little bit more with that. The other really big problem with static analyzers is they dump out a ton of false positives. And every time I talk to somebody that says, yeah, we bought Fortify and we spent $5 million putting that thing in, and we even brought pro services in to get it going, but it gave us so many false positives, we don't even run it anymore. I've heard that bunches and bunches of times. What you want to try to do is get into an environment where understanding what your false positives are that the analyzer is giving you, and then just throwing those results away or filtering them out if you can. So what ends up happening when you build a secure software development lifecycle is you have all of your tools plugged in, right? Most of the static analyzers out there, I saw yesterday Checkmarx is here. They've got an IDE integration. Baracode has one that I'll demonstrate here in a minute. HP has them. Just about all of the static analyzers will plug right into your IDE. So the developers don't even have to leave their environment to see their defects come, and I'll show it to you here in a bit. But what we typically do is have a developer write code and either check that code into the main branch, and then a build server will build and scan, or we can just have them scan it themselves right out of their IDE environment, find the problems, fix them right there, and then get the code to deploy. Couple that with using something like your build environment to build for Fortify or Baracode or whatever, ship that code up and have it scanned. When the developer comes in for the next day's work, they can just pull those results down, they have them sitting right in front of them, and it's really easy for them to deal with the problems. If you're doing it this way, rather than finding 500,000 problems, you only find 30 or 40 the first time that you sweep through this. What also happens is a developer, the cycle of understanding between writing the code and finding the flaws becomes so short that they organically understand, oh, I shouldn't use that library anymore, or I need to take this input and run it through a validation routine, or I've got to do some kind of control flow on this data that came in. And they understand it at a much, much more pertinent level, and it allows for them to organically change the way that they code and make it better. So continuous integration is your goal, right? What you want to do is have your Jenkins build kick the thing all the way up to have the source repo analyzed and then scanned, and then give you the information back. You have a question? Bytecode versus source code. So here's my take on this, and I'll tell you right now, I worked at Baracode, so it's going to come a little that way. Source code is a lot of code on a page. I don't have any context or understanding on how that code is going to be run. If I'm analyzing bytecode or binary code, I do have a little bit of understanding of how it's run. The way Baracode does it is they instrument an environment and force data through the application. They see what happens to it. HP goes line by line and says, okay, you're picking up a parameter here, what are you doing to it? And it looks through the code and says, all right, I don't see any validation routine on this. You probably have a problem. And so it's possible to build continuous integration in either environment. So realistically, you're going to hook HP instead of into your build environment. You're going to hook it into your source repo and have it read it, right? I also like tools like Sonatype for this. Sonatype's not really a static analyzer. What it does is it looks at libraries that you're using, all the third-party stuff, and it says, all right, well, you're downloading this Java library that we've known for 8 years has vulnerabilities in it. The better one is down here, and you should upgrade to that. So what we're trying to do is get to the point where we have continuous integration. The development, your build cycle, your OPSEC team, whoever is involved in development understands this. So I'm going to drop out to what an IDE integration looks like, just to show you how this can be a lot easier for any organization to use and to put together. So in this case, it's Baracode. I happen to have a Baracode account. Please don't, this is not a Baracode sales pitch. This can be HP, Checkmarx, whoever. I just don't happen to have a Checkmarx account. This is Eclipse. I've got an application that I'm writing here. I went ahead and up at the top of the application, I just installed the Baracode plugin, and I can say upload and scan. It will push my code up to Baracode or whoever your service is, and it will go run the analysis on it. Once the analysis is complete, I get an email and I just simply say download the results, and it publishes the results for me right in the IDE. If this particular branch was sitting here on the screen, all I have to do is double click on this. It'll take me to the line of code that I need to go fix, and it'll help me fix it. So realistically, making security part of the development lifecycle is not a difficult thing. It takes me about, I don't know, 2 minutes to get this instrumented and functioning, and you can scan in a way that nobody is watching you over. If anybody here has ever used Veracode, you know you do policy scanning, so you set up a policy and you say what things you'll allow, what you won't allow inside your policy. It's a lovely noise, it's great. And once you have that built, everything gets evaluated to that policy. But in this case, we can do something simple and say, just scan it and tell me what my problems are, right? So no policies associated, nobody's looking over your shoulder. You never want that contention between security and development, or security and anybody really, because eventually the tools will just won't get used anymore. So static analyzers should be instrumented as part of the development lifecycle, but as we move up into QA, there's plenty of things that we can do there as well. So what I like to do when I talk to the QA organization is I say, have you ever used any security products? And the answer is almost always no. And I say, well, you know, there's really great free products out there that you could just put in and use. So for instance, during QA, oftentimes there are places where we input integers. You have to ask yourself the question, well, what's that bounded set look like? Can I put in 10 billion? Can I put in all nines? And all nines means 9 million nines. Can I put negative numbers in, right? Bank transfers of negative balances are always fun. So what we do is we approach the QA organization and we say, hey, why don't we put security in as a step here? You're looking for the button. Is the button blue? The story told me that there's supposed to be a button and it's blue. If the button is not blue or not there, those are code defects, right? QA speaks to development in the language of broken software. Hey, this is a defect that we have, or this is a problem that you need to go fix. And so what we're trying to do is get to the stage where security bugs and function bugs and really any code bugs are just code bugs. We're not trying to point fingers. We're not trying to say, hey, we've broken security in some way. And so what we try to do is just get QA to be part of this team, right? Usually this requires a little bit of an education component. Sit down with your QA guys, take them through a secure coding class, give them CBTs on secure coding, whatever that means. Train up your QA team so that they understand what software bugs associated with security look like. Teach them how to detect security flaws. Doesn't have to be extremely deep training where they spend all day reading books on web application attacks. It can be fairly simple. But the reason why you want to embed this in QA is because they speak the language and they use the tools that development is used to. So whatever defect tracking system it is that you have that security doesn't have access to, for sure the QA guys have access to it. And so they're going to be able to do defect reporting and stuff quite easily. You can also create much more meaningful tests this way. And it allows for you to get your QA guys on board with this whole security idea. So what I'm going to do now is just fire up Burp. Anybody here use Burp? Familiar with Burp? A few. So I'm running basically the most recent version, 39. What I'm going to do is simply take my web browser and tell it to listen or to start speaking to my proxy. And I've got this web application called the Budget Store. And what the Budget Store is just a broken web app. It's an application that I worked on for a little while. And it allows for me to do demonstrations of, this is a retail store, if you will. So whenever I see a web application that has any kind of search or places for input, I immediately start doing things like this, where I throw, some kind of alert at it. and it pops a box up on the screen. Okay, we've got cross-site scripting. I validated it. I ran my script in this app. That's a problem. We need to now go fix this problem, right? But the other thing that we also can look at here is, well, what can I type into this box? How long can I type? Is it going to accept input all day? Maybe it is. Maybe we don't want that. Maybe we needed to validate that this only accepted 10 strings in this input. And so I stick this in there and it gives me this craziness, right? So if I move over to burp, I can pretty easily drop in here. Sorry, I got to add scope. That noise is awesome. Whoever's phone is on vibrate like that, that's crazy. You're going to hurt yourself, I promise. That's not it. Also not it. That's it. So you can see here I opened up the page, and you can also see here where I have a parameter that I inserted, and you can see the script tags that I sent out, and you can see the response from the web server that came back. What I'm going to do if I'm working with a QA team is I'm going to say what we want to do here is move this over to a tool inside Burp called Intruder. And what Intruder is going to do is it's going to look at my requests that I've made, and it's going to say, all right, I see parameters here. So what I'm going to do is help you. I'm going to mark all these parameters up. This is never useful. I don't know why DAF did this, but every time I do this, I go clear the parameters out, and I say, all right, the one I really care about is this one, right? And your QA team can quite easily go, all right, the Q parameter, okay, what we're going to do here is really mess with this thing. And all I have to do is go like this and say add, and now I've put a token on this parameter. Anything that I want to do from now on is going to change the values inside of this token. So if I want to do something like negative value testing, I can come in here and say, all right, what I want to do is a -1, right? Maybe I want to do a -1,000. Then I just say start attack, and it'll run through and drop those parameters in place, and it will give me responses back. And I can see what the server has done with the information that comes back out of the tool. If your QA team has an understanding of how to test these parameters, they can build a test load scenario, right, for negative numbers, positive numbers, whatever, a billion A's, however it is that they want to test these things. They can stick them in here and test with it, right, as part of the QA process. It's quite simple to do. I mean, I've just done it on stage here. Obviously, I know how to use this tool, but it only takes seconds to teach someone. The tool is free, which makes it a lot better. The way I showed it to you is the free version. If you want to spend the $350 on this, you can come down here and say, instead of the payloads where I add them in manually, I can pick them out of a list and run the payloads off the onboard list. But the free version allows for you to type in whatever it is that you want. So your QA team can add a new tool to their suite, and it costs them nothing, and they can start doing security testing right in the QA process. So moving out of QA, let's talk about operations, right? So we move this thing into production. It's sitting there all happily running. You've got your store up. Anybody can buy all the whatchamacallits that they want. And that's going to generate logs, right? Logs are going to show things like log in, log out, the requests that are made to the application. What we're going to do is just simply instrument our logs so that the logs will tell us when things are going wrong, right? So all of the application attacks that happen are going to be visible in your logs. And if you've ever seen a data breach happen across a web application, you can just go to the top of the log file and scroll as fast as you can, and you'll see it, right? This big blob will go floating by, and you'll go, oh, there it is. So if the human eye can pick that up, for sure, computers can do it way better. And so instrumenting your logs with some sort of alerting mechanism is not that hard. You can do this with Python or Perl, just grepping across the logs, or you can use something like Splunk. Most organizations that care about their logs have Splunk anyway. So the title of this talk is Application Security with the stuff you already have. So I'm assuming that you have Splunk, but if you don't, you write some scripts and then you'll have it. But most organizations look at their logs as an artifact. I worked for a company that was contacted by this guy in Finland who said, hey, I found cross-site scripting on your website. Anybody ever have this happen? Somebody contacts them and says, you got problems? Nobody raised their hand? All right, well, this guy lives in Finland. His name's Jan Alberg, and he's after you right now. So Jan sent us an email and said, hey, I found cross-site scripting on your website. You should go fix that. And I said to myself, I wonder what it looks like when he's trying to attack someone. So I went and looked in the logs, right? And in the logs screamed it. Here's all these script tags and craziness coming across in this parameter. It was right there. We didn't know he was doing it until he emailed us because we don't monitor the logs, right? This is with different companies, not the one I'm now. And the reason why I'm standing here and telling you this thing is most organizations look at the logs as some kind of artifact. We can go back to this thing and dive into it later. But I'm telling you right now, all of the activity that's happening in your logs right now is stuff that you should care about right now, right? You should be looking at your logs. So why not use your logs as a real-time alerting tool, right? So you instrument your logs. Some attacker probes your application. They send in cross-site scripting tests, or they send in some kind of SQL injection probe, whatever the thing is, right? Your application is going to log all the requests that come flying in. By the way, give it a lot of disk space. If you crash because of your log disk, that's just comical. You shouldn't do that. What you need to do then is correlate the logs. You got to have some kind of engine that will run through your logs, index the data that's there, and understand what's in there, right? And then instrument some alerting, so that way you can be notified when an attack is happening. So let's look at what a probe looks like inside of the logs. And in true demo fashion, I tested this last night, worked perfectly. This morning, my license is expired on Splunk. As you would expect, live demos never work right. But if I just simply come in here and I look for things like, do I see the word test, I can scroll down and you can see, I scroll down a little bit and you can see I threw this test at it this morning when I got my licenses all back up and running. I threw this little scripting test at it, and sure enough, the log is seeing it. What's great about Splunk is I can now mark this up and say, if you see events like this, text me, tweet, whatever it is that you'd like to use as your alerting style. You can have it pop an alert to you that says, hey, you're being probed right now. Somebody is looking at your application. You are under attack. And you can use this information to have your SecOps team, your DevOps team, whoever your team is that's monitoring production, suddenly start looking at things. Well, what's the source address on this? Where's that coming from? Maybe we can just geofence this area. For sure, if you start seeing attacks like this and they're originating from Finland, I can give you the guy's email address that's doing it. And there's a few of those guys out there. Jan, by the way, is only interested in security. He didn't want money. He didn't even want a t-shirt. He just wanted us to not have cross-site scripting on our website because he wanted to stop malware from spreading around. But not everybody's altruistic like that, right? So your logs are screaming the problems that you have, but you're using them as an artifact and you're going to look at them later, right? Does anybody know what the average time is to detect that you've been breached? It's over 6 months, right? The target breach went on and on and on, right, for a really long time. So keeping your logs for a long time is a good idea, but wouldn't it be better to just notify you right away, hey, you're being breached right now, you should probably take a look at that? That's a little bit better way to approach the thing. All right, so something that I just stumbled across. Sure.
Right. So all you're going to be doing is sending false positives to the search team, and they're going to just get pissed off at you.
Sure.
Right. What you want is basically a way to send them only things that are exploitable. How do you tell that from just a log?
How do you tell if it's exploitable from just a log file? That's it's a difficult problem, right? Like that's not a really simple problem to solve. I won't be able to tell you that it's exploitable. I will be able to tell you that you're being probed, which is the first step, and it's important, right? If you don't want to pay attention to the alerts, you don't have to. But if you drive in and look at, this guy has thrown 58 script tests at me, for sure, you're being probed by the dude. Sure. It does, but the reason I'm bringing this up is I've walked into hundreds and hundreds of organizations that aren't doing this, right? Yeah, that's another good point. Yeah, if you generate enough noise, there won't be enough signal for anybody to care, right? And it's a good point. It's something that you have to be careful of and mindful of, but if you know that you have specific parameters that are vulnerable to a thing and you don't have a WAF, this is a good way to instrument it and find out. So we stumbled across this thing. My boss actually found this for me. We were doing application security review for an organization that has all of their stuff hosted in Amazon. And they said, well, could you take a look at the way we have our permissions set for our application services and our security groups in Amazon? And I said, yeah, sure, send me the AWS CLI output. And they send you a file that looks like this, right? If you go into your Amazon environment and do an AWS CLI output for your security groups, this is what you get, except it's way longer. So it's just pages and pages and pages of these IPs can touch this security group, which can do this thing. And it's a real pain to sort through it and figure out, are there redundant IPs, or you have overlapping space here? What are the potential problems? So we found this really great tool out on GitHub, and if you just Google AWS Visualizer, that'll get you there. And what's really great about this thing is it takes all of this JSON output and turns it into a visual representation of your security groups. So here's a screen cap of it. But if I move out here, this is a little bit better. It's an SVG file, so it renders a little bit weird in a web browser, but you can immediately see the value. At the top are the IP addresses, and then in the middle, it's your security groups, and at the bottom, it's what they can do. And as you scroll through this thing, stuff starts to immediately leap out at you. For instance, here's a 10 address space with a redundant host route inside of it. So I asked the question, well, why is this redundant host route here? It seems like you're duplicating effort and creating problems all at the same time. It turns out Amazon forces this onto you. You can't undo it. And what it is I think enough people have gone in and deleted things and then called Amazon and said it doesn't work, that they force this route on you so that things will stay connected and keep working. But as I went through the analysis of this application, I said, well, there's a bunch of public IP addresses here. Now, this has all been cleaned up. It's not their addresses, so don't go writing it down. None of this will make sense. But I went through it and I said, well, can you give me a list of the known IP addresses that should be connecting to things? And they gave me the list, and I looked at the top, and I found an IP address in there that did not exist in their known list. Right? And I said, well, what is this thing? Oh, yeah, we put that VPN box in like 2 years ago, and we ripped it out last year. Well, they left the security group stuff in their AWS environment. So for sure, there are things hiding in places that we all need to go evaluate. This doesn't cost anything. This tool is free. If you have a Kali box, all you have to do is gem install AWS Visualizer, and you're done. It will process the JSON data for you and output it like this. So free tools are always fun, free as in beer. But this is the way that you want to do this thing. Any questions? Awesome. So a few successes, organizations that I hold up as organizations that are doing things well. We work with a lot of financial organizations, big organizations, that oftentimes when you walk in and say, well, tell me what you're doing for application security today, I almost always get this. Well, we've got 1,500 applications. 7 of them we care about, and we don't do analysis or security on anything else. Right? I hear that a lot. All is a difficult problem, right? You want to look at all of your applications. And I hate to bring up Target over and over and over, but Target had an application that they didn't care about, and look what happened to them, right? It's an example of what can go on. So what you want to try to do is look at all of your apps. If you start to trunk this into your development life cycle, you can get all the apps that you develop. If you build a vendor security program that's more than just SurveyMonkey and spreadsheets, you can end up with all of your inbound applications cleaned up. We worked with an organization over a couple of years that's a healthcare organization, and they always have to do things like conform to HIPAA, or there's some kind of policy that's held over their head that they have to go live by. And what ends up happening is a myopic focus on just that. I need to be HIPAA compliant, or I need to be whatever compliant, and they push to go that way. Those of us that work in security know security delivers compliance. Compliance does not deliver security. So if you have a secure environment, you end up like this. All the techniques that I brought up today were implemented by this healthcare organization. I think they're here today. They've spoken publicly about this, so I'll mention their name. It's the Mayo Clinic. They have built an environment where all of their code gets scanned every night for all of their applications, gets pushed up through build services, etc. All of their development staff use IDE integrations to look at all of their applications. Anything that comes from a vendor has to go through a vendor assessment process, which they make their vendors pay for. You will deliver me this report as you get this done. And what I love about this is Jim Nelms, who was the CISO for Mayo Clinic, he'll explain to you that good software security pays for the tools that you need for it. If you let it go, you're going to end up with high cost in trying to repair things. If you fix it early, the money that you spend on the tools that you have is going to be given back to you in huge ways. Some other things to consider. I brought up Sonatype and organization. There's another one out there called Black Duck. If you're using any open source software or software that you don't know where it came from, start looking at these kinds of tools. Understand that when you go pull down a library, that library may be vulnerable. That library may be 15 years old and vulnerable, right? A lot of the software that's on the internet today is an abandoned master's degree project, right? So you have to keep that in mind if you're pulling these things down. Have you thought about maybe just instrumenting your applications so that it doesn't really matter what your developers do? They're starting to come on board these new terms, RASP and IAST. I just looked at a company called Previty when I was out at RSA, and they will instrument your Java stack so that it doesn't matter what kind of input validation routine you run, they'll do theirs. Granted, it's kind of signature-based-ish thing, and it only blocks certain things, but if you're being plagued by cross-site scripting, it's a pretty good and easy way to get rid of it, right? Just let your devs make the mistakes and clean it up with the tools that you have. So no matter how you build it, something that your vendors are never going to tell you, you need to buy the tools that work for your thing, right? Checkmarx is always going to tell you we cover all applications, but if it doesn't cover your application, it's useless. So bake-offs are really important. You should do them in broad scale and look at all the different types of services that are available to you. If you don't spend money on pro services, you need to spend time on pro services. Instrument the stuff, put it together, make it part of your software development lifecycle. If you buy a widget, make the vendor train you on it, right? We often see shelfware due to untrained drivers, right? They just don't know how to use the thing, so they don't do it. And plug it together as much as you can. Any information or data that you can then glean that data and use it for something else. And it's a really good idea to have a development lifecycle that uses all of the tools and all of the communication mechanisms that you can. That's the end of my time. If you have any questions, you can ask them now. I think I have 60 seconds left. Or you can stop me at the end of the thing. Thank you very much.